This video is for lesson 23-3 about the law of cosines. We're not going to take the time to prove the law of cosines, but we will solve some problems using the law of cosines. In the previous lesson about law of sines, we discussed a real-life situation about fire spotters on the lookout for forest fires. Let's talk about a similar problem. Fire spotters are located at stations A and B in the forest, and they see a fire located at station C. What is the distance between station B and the fire? So it's this side of this triangle that we want to solve for. I notice that that side of the triangle is across from capital A, and so we should label it lowercase a. Across from capital C is the 14 kilometers, and that's lowercase c. Across from capital B is the side with 10 kilometers, and that's the lowercase b. Now, to solve for lowercase a, we can't use the law of sines like we did yesterday because we don't have the right combination of numbers for our different lowercase and capital letters. If we tried to make a proportion, we would end up with more than one variable in our proportion. I'll show you what I mean. If we want to solve for lowercase a, our proportion would have to have the letter A in it. And so we could say the sine of angle A, that's 38 degrees, is to lowercase a as, and now which letter should we use in our other fraction? Should we use C or B? Remember that we need to choose a letter where we know numbers for the capital and the lowercase letter. We can't do that. We don't know the angle at capital C, even though we know lowercase c. We don't know the angle for capital B, even though we do know lowercase b. We don't have any way to write another ratio over here where we have a number in the top and in the bottom. So we can't use the law of sines. But the problem is still solvable. We're going to use the law of cosines to solve this problem. If you look down just a little bit on this page, you will see the law of cosines. You'll actually see three versions of the law of cosines. All three of these need to get on your note page at some point. Now, what version of the law of cosines you use depends upon what letter of the alphabet you want to solve for. If you're trying to figure out lowercase a, it makes sense that you'd use this first equation because it's the one that has the lowercase a alone on the left side of the equals. But if you were trying to figure out lowercase b, you'd want to use the second version of the law of cosines. Which one should you pick if you want to solve for c? Well, you'd pick the third version. So in our problem, we want to find lowercase a. We're going to write out the law of cosines formula that has the letter a alone. It's a squared equals b squared plus c squared minus 2 times b times c times the cosine of capital A. I know that looks really complicated, but that's why I say to write this down on a note page so that you have it on test day. Now let's make substitutions. The lowercase a is the letter that we're solving for, so we don't know the number to plug in, so we'll leave it as a squared. We do know lowercase b. We can fill in the 10. We do know lowercase c. We can fill in the 14. Minus 2 times, for lowercase b, fill in the 10 again. For lowercase c, fill in the 14 again. And then times the cosine of capital A. That's 38 degrees. Notice that by using the law of cosines instead of the law of sines, we do only have one variable in our equation, so it's solvable. Let's do a lot of work on the right side of this problem. 10 squared is 100. 14 squared is 196. Minus, okay, this part right in here, 2 times 10 times 14. That's 280 times the cosine of 38. We can add together the 100 plus the 196. That's 296. Regardless of how much of this work you choose to do by hand, at some point you're going to get to where it's time to type it on the calculator. So please take your calculator and type this in exactly as you see it. 296 subtract 280 times cosine 38 and push enter when you get to the very end of that. This makes 75.3. Now we don't quite have the letter A alone, we got the squaring left. So last step, let's do the square root button on the calculator. Please take your calculator and find the square root of 75.3. And the answer is 8.67 kilometers. So in this context about looking at a forest fire from a tower, we found that the fire is 8.6 kilometers from Tower B. Let's skip ahead to number 9 and try another one. Fire station towers are located at points A, B, and C, and the distances between the towers are known. I noticed that they're 8 kilometers, 5, and 11 kilometers. Spotters in the towers don't know the measures of the angles between the towers. What we're specifically asked in question 9 is, what is the measure of angle C? How many degrees is that angle? Well, to find this, we can't use regular trigonometry because it's not a right triangle. We can't use the law of sines because in the law of sines, you have to know at least one of the angle measures already if you're going to make your proportion have only one variable in it. So we're going to use the law of cosines. Now there's 3 versions of the law of cosines. Which one should we choose if we want to figure out angle C? We want to pick the one that has the letter C alone. It looks like this. C squared equals A squared plus B squared minus 2 times A times B times the cosine of capital C. Now we could make substitutions. What do you put in for lowercase c, for lowercase a, and for lowercase b? Here's where it's helpful to know where the lowercase letters are relative to the capital letters. Remember, the lowercase letters are always opposite from their capital letter. So across from capital A is lowercase a. Across from capital B is the lowercase b. Across from capital C is the lowercase c. So for lowercase c, fill in 11. For lowercase a, fill in 5. For lowercase b, fill in 8. For lowercase a, it was 5. Lowercase b was 8 times the cosine of angle C. So remember, it's the capital C that we don't know the answer for. That's where our variable is. Okay, so we have this very long equation, but it has only one letter in it, capital C, so it's solvable. Let's take this one step at a time and work our way down. 11 squared is 121. 5 squared is 25. 8 squared is 64. Minus. Now these 3 numbers here, 2 times 5 times 8, that's 80, times the cosine of C. The 25 plus 64 we can add together. That's 89. Minus 80 times the cosine of C. Next up, subtract 89 from both sides. 121 subtract 89 is 32. And that's equal to negative 80 times the cosine of C. I can tell you already that there's a potential spot here for an error. And that is, if you go 89 minus 80 and say 9, instead of subtracting 89 from both sides, you're going to get the wrong answer. Okay, next step, let's divide both sides by negative 80. Those cross out, and the cosine of capital C is now alone on that side of the equation. On the other side of the equation, 32 divided by negative 80 is negative 0.4. One step left. We have an equation that has the trig function cosine in it. We want to get rid of the word cosine so that the capital letters alone. That's inverse cosine. So capital C is the inverse cosine of the negative 0.4. And the result is 113.5 degrees. In this picture, that kind of looks obtuse, and so getting an answer of 113 degrees is reasonable. So notice that we could not use the law of sines to solve for unknown information because it wasn't possible to make a proportion that had only one variable in it. Instead, we used the law of cosines. The first thing we had to do is choose which version of the law of cosines to use, and we picked the one that has the letter alone that we're interested in. In this case, we chose that one here. The letter C was alone because we wanted to know something about the letter C. Make a whole lot of substitutions, and then start working it out step by step until you finally have solved for the variable that you want.